Okay, almost there, folks. Last presentation. Thank you for this opportunity to talk to you this afternoon. My name is Keith Jones. I'm not an earthquake engineer. I'm not a seismologist. I'm actually a facilities manager who has experience in developing resilience plans for businesses and critical infrastructure organizations, not necessarily for specific stresses, so not necessarily for earthquakes. In fact, the ones that I've done previously have been primarily for climate change. But my role in this project is to look at how a system like TURNkey could actually be integrated into a business organization's disaster management and business continuity planning. So I get to ask at this stage the so what question. So what is the real impact that TURNkey could have from a business and critical infrastructure perspective? So what I'm going to try to do in the next 20 minutes is to go through the planning process that a business organization would go through and try to duplicate and show where some of the examples that my colleagues have shown today can be translated from the municipality level, which Alberto has just demonstrated, and actually a very similar set of applications could be used at the organization level. I've been helped in this by colleagues from across the TURNkey project and also by a number of our stakeholders throughout the testbeds, who over the past 3 years we have worked closely with to understand how they respond to an earthquake at the organizational level and to look at each of the steps of their response and ask the question, so what could TURNkey do here? We haven't got full answers. We don't have a fully working system for second level users, but we have hopefully demonstrated the role of TURNkey as a decision support tool. And so I'm going to take you through TURNkey, but not as an engineer, not as a scientist, but as somebody from the business perspective. And I'm going to look at TURNkey from the point of view of resilience. And I'm going to start by explaining what I mean by resilience, and then just a few slides to show how TURNkey could be used. We are using an example of a hospital. It is a hypothetical example. It is synthetic data. It doesn't represent any single hospital. It is drawn from information available from Oriella, but also from Los Angeles, from India, from FEMA. And we've taken best practice guidance given to a hospital organization from all of those sources and tried to put it together into a simple story. So, let's look forward. Let's look at how TURNkey could be used to help a hypothetical hospital located somewhere in Alicante. And in particular, want to look at how TURNkey could be used in simulation mode before an earthquake to help the hospital understand its risk, how it could be used during an earthquake to help the hospital manage its specific recovery, which is aligned with the role of emergency responders and civil protection, but has additional functionality that looks at specific operation of the hospital or business. And then finally, how the app could be used not only by the emergency responders and civil protection, but potentially by the hospital's own staff as they go about trying to clean up after an earthquake and restore full functionality, which in some places could take many weeks. So I want to talk about resilience and vulnerability, but from a slightly different perspective. So every organization has an inherent vulnerability to a disaster. it also has an inherent resilience. And these are factors that have come about over time because of the way the organization has evolved and has developed. And this model is based loosely on an interpretation of a model developed in 2008 and 2010 by Professor Cutter from the States. And she argued that resilience should be considered as an overarching concept that combines a number of systems. I'm sorry if you can't read the slide, but the bottom line says that resilience and vulnerability depends on your buildings, depends upon what buildings you have and what systems. It also depends on what you do within those buildings. So the building is there to serve the primary function of the organization. It has processes and it has facilities which could be susceptible to damage. They have their own vulnerability and their own resilience. It also has the business systems, the context within which the organization works. Taken together, those influence and affect the actual impact that the earthquake could have. So if there are mitigations in place, business continuity plans or disaster management plans, then they can reduce the impact, or at least they can improve the absorptive capacity, the ability of the organization to cope with the impact. In turn, that then leads to its recovery. Does it recover quickly or does it recover slowly? And of course, feedback. So once you've had a disaster, can you develop better plans for the future? Can you actually develop better continuity? So that's resilience, and within that you have business continuity and disaster management. Now this comes from an international standard, an ISO. And the ISO identifies a number of steps. So you have to have pre-earthquake planning. You have to have a team responsible for assessing and identifying the risks and the responses. I believe that in this context, TURNkey can help through coordination, and we've already seen how TURNkey can contain information about the organization, about its teams, about its management, about its units. Then you need to understand the hazard and the threat and the risk, and we've seen the simulations. And TURNkey can run as many simulations as you want. So we can allow the management to play what-if scenarios. For these, then you can develop specific impact and capabilities. You can understand the potential damage states and losses that could be generated. You can develop your specific plans, your emergency evacuation plans, your workaround plans, your business recovery plans, and you can then integrate early warning and the rapid response into these plans to help you better prepare. And finally, you have testing and training, so you can run the simulations as part of a training exercise, either within the organization or as part of a wider regional training exercise. So that's the TURNkey model. You've seen it before. I'm not going to talk about it except now to focus on these two: critical infrastructure organizations and businesses. And they communicate as secondary level users to the platform. So they are not the primary users of the platform. They work through the region. And the information they get is filtered by the region. So they are not autonomous. However, if the region chooses to make the health sector autonomous, it can do so. But initially the design is to work through the organization. It can communicate information and it can receive information from the platform. You've heard about the scientific engine and you've heard about the graphical user interface that can be used by the organization as part of its planning. So what does a business or a hospital need to do if the region has decided to invest in TURNkey? Well, it needs to provide some data. It needs to provide specific information about its built assets and about its procedures and about its plans. It needs to populate the system. It needs building data, number of buildings, the type of buildings. For each building, it needs to be able to identify them, to give them a classification, to give them a taxonomy, to give them a location, to describe their use, to give them a size, and to give them an occupancy type. It needs to give some cost information. So some unit costs for replacement, some structural costs, non-structural costs. Now, one of the things that's often forgotten in disasters is that it's actually the functional performance of the units inside the building that are critical. And even at minor damage states, you could have non-structural components which are damaged, and therefore the functionality of the whole unit is reduced. You need to tell its vulnerability, and you need to give some data. Now, I'm not a seismologist, but all of this data is contained within most hospital organizations' emergency management plans. So I was lucky to see a copy of one of the local hospitals' plans as I was going through this. And this information is there. It's not new information that is needed. You also need to give operational information, so occupancy levels at different types of day, staffing details, including contacts of key staff, because again, you need to drill down below the building to the department level. And each department in the hospital will have its own procedures for dealing with an earthquake. You need to give contact details and details of alternates, so the head of emergency, the head of intervention, the department heads, details of the intervention teams, etc. You need to have the contacts with the civil protection and the emergency responders so that you can coordinate communication. You also need details of your key suppliers, because you're going to have to repair damaged equipment. You may be able to do it yourself, but you may need to call in experts. You may have to restock. You may need alternate suppliers, because your suppliers may also be affected by the earthquake. So you need to provide a detail that will allow you to respond. You need your protocols, your evacuation plans, your alternative working procedures, your workarounds, that you can put into place quickly to get you over the emergency, the immediate response, but gradually you will remove as you get fuller functionality back. And then you need to put in any standard email. So we've seen the system can generate emails. Well, a hospital or a business can use that, either for internal communication with its own staff, or external communication. And one of the things that a hospital needs to do is manage communications with the press. So you can put in contact details around public announcements and the press. And Alberto's already shown you these slides, so I'm not going to go into a great deal of detail, but once the information is in, then your hospital exists not just as a single icon in a region, but with a lot of drill down information that you can move down different layers in order to respond to the earthquake. So you can see the location. There are 3 hospitals that were included in the synthetic data that is being used for Alicante. So with the system set up, how would a hospital management team start to use it? Hazard, threat, and impact. So you've seen the way that TURNkey can generate simulations. These simulations give you details of the hazard at different levels, at different scales, and in different time frames. You see how it can actually generate the impact at a regional level, at a sub-regional level, and the hospitals, in this case, 2 of them are located on that boundary, where the potential impact could be quite high. You can see how, in a simulation mode, the hospital can then say, in detail, what is my damage, what is my risk, and what is my cost estimate for repair of my building. So we've moved from the region now down to a specific hospital. And we can drill down through this data. So you can see the data that's been used to generate the simulation. You can see the expected functionality level, and you can see the losses. Now this now reflects data about the hospital, not the region. So you can start to see how you can build up a series of simulations that allow you as managers to ask the question, what do I need to do in order to manage this risk? So you could run different magnitude scenarios and get different estimates of PGA and of damage. You can look at the potential impact of each of these scenarios, and you can run as many as you want on your critical systems. Now, the hospital, your building is your critical system at the top level, but within that are sub-departments. And so you can look at what happens at the department level. Now, TURNkey won't go that far, but it will give you the general information which will allow you to ask your department heads or your specialist consultants, what is the impact of this level of shaking likely to have on my sensitive equipment? Is there anything I can do to isolate this equipment? And if so, when should I do it? If the risks are unacceptable and unmanageable, then you need to do something about it. So, seismic retrofit. Do I completely refit my hospital, or do I just refit part of it? I need to look beyond structures. So what about my fixtures and fittings? What about my non-structural components, which may not actually be damaged, but could have collapsed? Ceilings coming down. So how can I drill down in order to this level? If I think the risks are manageable, then what am I going to do to manage life safety? Most important thing. So what am I going to do about my emergency management plans and my evacuation plans? Am I going to integrate an early warning? And if so, how am I going to differentiate it from other type of warning that I issue? Is there such a thing for safe mode for my critical equipment? How am I going to communicate with my staff, with my patients, with the public, with my supply chain, with the people that I need to rely on in order to get back to operation? And my recovery plans. Now, detailed seismic rehabilitation is beyond TURNkey. The level of detail on the fragility curves, on the taxonomy, is not sufficient. But it is sufficient to allow you to say, do I need to instigate a full structural survey? Do I need to go that way? What are my options? So you can look at the performance of my existing building. Then you can change the taxonomy and say, let's run the same earthquake scenario, but now with a different taxonomy for a partial seismic rehabilitation. Are the reductions in losses? Is the improvement in functionality significant? What happens if I rebuild to the latest code? So what are those options should I investigate further? Which should I actually move forward? Now, TURNkey stops there. So it's a decision support planning tool at this stage of your business continuity planning. But it should allow you to make the decision of what to do next from a seismic rehabilitation, a built asset management perspective. So let's move on. We've developed our plan. We've done what we're going to do as far as retrofit. We're now facing a real earthquake. So, earthquake early warning. TURNkey's platform has early warning and rapid response capabilities. If those are integrated into your disaster management plan, then how are you going to use them? What does your plan say to do if the alarm sounds? Is it drop, cover, hold, as we were talking about this morning? Is it evacuate? Is there time? Is it automatic control of systems, if it is appropriate? Can you auto shut down very critical systems? Can you turn systems to fail-safe mode? This is very critical for systems which are very sensitive to shaking. Some systems you can, some systems you can't. If you can, what are you going to do? Again, improve life safety from your business continuity. The risk of aftershocks we've talked about on a number of occasions, and the early warning of aftershocks. At some point, the hospital will be allowed back onto the site. They will start their process of returning the hospital to functional performance. But there are still dangers. So can they make use of the system, particularly the app, and give it to their key responder teams in order for them to actually go around and have a level of protection? Activation of your command and control, not now at the regional level, but now at the hospital level. Early assessment of damage. So your building may not be severely damaged, but your functional performance may be. So using the app to actually report on the functional performance of your X-ray department or your CT, your scanning department. And again, taking the feedback and then feeding into training scenarios so that you can test your plans. The alarm will be sounded if a threshold is exceeded. And again, if a threshold is exceeded, that will appear in the organization's command rule if it's activated by the emergency responders and civic protection. They can also receive the alarms and the email messages. So not only can the first responders receive messages, but a different set of messages can be sent to your internal staff, to your internal response teams, asking them to meet or to initiate their plans. You can send message to your patients, advising them that you've cancelled all non-emergency appointments for the next 48 hours. So you're starting to manage the communication from a functional performance of the hospital with the people that are immediately affected. You can initiate your own predefined messages. Again, Alberto showed how you could generate social media messages. Organizations can use the same functionality to manage their communications and initiate their messages. The earthquake's been, you're still in that immediate response zone, but you've got to get back to business as usual. You've got to start to recover. So the final stage of a business continuity plan is to actually start to move forward. So damage estimates. An early estimate of damage. Why do you want that? Because in your simulations, you will have developed interventions based upon different scenarios. The quicker you know which is the closest scenario to what is happening, the quicker you can put the most appropriate set of actions into place. So you can change priorities, or you can set priorities for your internal staff, your internal teams. You can activate and monitor departmental level recovery plans. And you can communicate and coordinate. If you don't have a simulation previously run, you can run one based upon the early estimates of the earthquake. You can use the eyewitness reporting, this time not to look at the building level, but to drill down. You can generate and upload specific information at the departmental level. Again, this won't be entered into the engine until it is validated. That validation could be done by the hospital, or it might have to go through the platform operator. But still, it's a feedback loop that can start to generate better information about exactly what is happening on the ground. And again, the information is fed into the engine once it is validated, and then you can monitor the response. You can see what is happening, and you can get feedback on what is happening, and you can keep a record of what is happening when. So that when you need to learn from the system as you go forward, So you've got that feedback loop built in. So if you think back to my original diagram, we're in recovery, we need to learn. So this keeps a track of actions. You then have the aftershock warnings and the forecastings, which again, if you're linked in, can come straight through to the hospital and via the app to the staff on the ground, who can also then use the same function with their command and control to show that they are safe. So you can scale turnkey down from the region to a sector, so you could apply this across a range of hospitals to a hospital as we go forward. So to answer the question I asked at the beginning, what is the impact of turnkey? Well, I believe turnkey is a decision support tool. For businesses and for critical infrastructure, it allows them to do better planning. It allows them to consider their disaster management and business continuity in a more coordinated way, from beginning through simulation, through early warning and forecasting, to rapid recovery. So to go back to the diagram we started with right at the beginning, primary users of the system can assess vulnerability and risk. They can look at emergency response actions and they can consider recovery. Secondary users of the systems, in this case critical infrastructure and business, can integrate with those models. And they can then improve their business continuity planning and their disaster management planning. So thank you. Turnkey from a business perspective.